Consider this chemistry question. Which of the following gases may not be dried with concentrated sulfuric acid? So A, HCl, which is hydrogen chloride gas. B, N2, which is nitrogen gas. C, Cl2, which is chlorine gas. D, SO2, which is sulfur 4 oxide or sulfur dioxide. E, NH3, which is ammonia. So very good. We want to know which gas among these 5 gases cannot be dried with concentrated sulfuric acid. Sulfuric acid is tetraoxosulfate 6 acid, which is H2SO4. One of the properties of this is that it is a drying agent. It is used as a drying agent. So because it belongs to family of compound that we call the hygroscopic compound. Hygroscopic compounds. So these are compounds that absorb moisture when they are exposed to the atmosphere. So, and as a matter of fact, this is the only liquid hygroscopic compound. So because they absorb moisture from the atmosphere, they are capable of drying so many other substances. So, and you know that H2SO4 is an acid. So for it to have effect, it can only dry something that is probably another acid, so that cannot react with it, or a neutral substance that cannot react with it. So it will be able to dry those ones. But if you combine this with a base, it cannot dry the base. Instead, it will rather react with the base and form salt and water. So now, we will now look out for these options. We look out for the one that is a base among these. So any base that we have here, this sulfuric acid cannot be used as a drying agent for it. But any other one that is maybe acid or neutral substance, so drying agent, so sulfuric acid is used. So let's consider the first option. This is HCl, which can be called hydrochloric acid or hydrogen chloride gas. So this, if you use H2SO4 for it, this is an acid, this is also an acid. So this will surely dry it because there will be no reaction. This is acid, this is acid. The two acids cannot react together. So it will not, this cannot be the answer because the question says which gas may not be dried. So it means automatically this can be dried by H2SO4. Let's consider the second one. This is N2. This is a gas. This is nitrogen gas, and it is neutral in the context of acid-base reaction. So acid-base reaction leads to salt and water. Since this is neutral, it's neither acid nor base. So then H2SO4 can be used to dry it. So that means this is still not the answer because the question asks for the one that may not be dried. Let's check chlorine gas. Chlorine gas too is also neutral in this context. So it's neither an acid nor a base. So let's consider the fourth one, SO2. SO2 is sulfur 4 oxide, or we call it sulfur dioxide. So which is a base, which is an acid. It is known as acidic oxide. Acidic oxide. So anytime a non-metal combine with oxygen, they always form acidic oxide, except in some special cases where they will form neutral oxide. So like this now, SO2 is an acidic oxide. So that is, it is an acid, as you can see it. So in fact, we call them acid anhydride, like SO2. We call it acid anhydride. When you pour it inside water, it dissolves in the water to form the corresponding acid. So now, SO2 is an acid. So it means acid and acid, this can dry it. There will be no reaction. So this can also not be the answer. But consider option E, which is ammonia. Ammonia is a base. So ammonia is a base, even though it's a weak base. And H2SO4 is a strong base. So when we combine both of them together, the reaction is a neutralization reaction. will lead to the formation of salt and water. This is how the reaction will go. It will lead to the formation of ammonium sulfate, NH4, SO4, then NH4 to SO4. Let's consider this whether it is balanced. So we can just put 2 here to make the equation balanced. So this is balanced. So this is the neutralization reaction. This is ammonium sulfate, which is made up, which is a salt that contains water content in it. So this reaction shows that ammonia will react with the acid, and so that means this acid cannot be used to dry ammonia. So, but other ones can be dried by H2SO4. So the correct answer is option E. Thank you. God bless you.